So we're going to go through a couple word problems together and using everything we've done with arithmetic sequences so far to create these equations. So in this first question, I've been given data about different rows and how many blocks are in each row. And our job is to create an equation or a formula that describes the number of blocks. So what I'm going to do is start by making a table. And I'm going to put the row as the input because the row that we're on is going to help us determine the blocks that are in that row. So for row number 1, he had 1 block. He put 3 blocks in the second row and 5 blocks in the third row. So every time I go up 1 row, I've gone up 2 blocks. So I'm going to make an explicit formula in this case. I need both of these pieces of information, and I need the common difference, because what I'm going to fill in is my first output plus my common difference times my first in, or excuse me, this is going to be n, this will always be n, minus my first input. So an and n are the two things that are going to stay exactly how they are. This is always going to represent an output value. So my first output that I see is 1. My common difference is a positive 2. And then I have n minus my first input of 1. And that would be my explicit equation for the number of blocks. My next question, I have how much the house was worth when it was purchased, after the first year, and after the second year. So again, I've been given information over a number of years. So I'm going to go ahead and make a table. Input will be year, and then the output will be the money that the house is worth. The money depends on what year it is, not the other way around, and that's how I know that year is my input. So when I first purchased the house, it was worth $350,000. Because I've just purchased it, no time has gone by, so my input will be 0. After the first year, it's worth $335,000. So that will be my next input in my table. And after the second year, it's worth $320,000. So for every year that we've gone up, the house price is going down $15,000. So again, I'm going to use that same formula we did before. I'm going to have AN equals, my first output was $350,000. And now it's going to be minus, because my common difference is negative. And then it would be n minus 0. So all we need to put is n, because minus 0 won't change anything about our equation. Then I have to do after 6 years. This means that n is equal to 6, since year is n and money is a sub n, my output. So I'm going to look for the output at year 6. That's what this means right here, the output at year 6. And that's going to be 350,000 minus 15,000 to too many zeros, times 6. So quickly in my head, what I'm going to look at is 15 times 6 instead. So I'll do 10 times 6 and 5 times 6 and add them together. So 10 times 6 would give me 60. 5 times 6 is going to give me 30. Those two things added together would be 90, but it was 15,000, so this will be 90,000. So I have to do 350,000 minus 90,000. So I can think of 35 minus 9. Which should give me 26. So this will be 260,000. That's how much the value of the house would be after 6 years. All right, next one we're going to look at is question number 3. She saved $5 in the first week, increased her weekly savings by $1.75, and our job is to figure out how many weeks. I'm going to focus this a little bit better. How many weeks it takes our money to get to $20.75. Now, we don't have information about a variety of weeks. We have information about the first week and how much it's increasing each week. So I have all of my information for my equation right away. So I can find my first input, my first output, and the common difference. So my first output is how much money she has at the beginning, so that's $5. It's the first week, so that means my first input is 1, and she's increasing her weekly savings by $1.75. So I can go ahead and put this straight into my equation. First output is 5. Common difference is 1.75. And in parentheses, I'll have n minus my first input of 1. Now, AN is my output, which is a dollar amount. So this dollar amount here is going to replace AN. So my goal is to find the number of weeks, so I'm solving for N. So the first thing I would do is subtract 5 from both sides. So I'll have 15.75 is equal to 1.75 times n minus 1. Oops. Now you can distribute or you can divide. It doesn't matter. You'll get the same result in the end. I'm going to go ahead and divide first. Now you could do this with your calculator very quickly. Since it's 0.75, I'm going to think of this as quarters. So how many quarters are in $15.75? Well, 15.75 is $15. Each of those is 4 quarters. So 15 times 4 is going to give me 60. So I have 60 quarters from the $15, and the 0.75 is 3/4, so I'll have 60 3/4 for the 1575 divided by however many quarters is the $1.75. Well, it's 4/4 for the dollar, 3/4 for the 75. So this is going to be 63 divided by 7. That's the equivalent division problem there. And if you use you may know this off the top of your head, but maybe not. I did the nines trick with my fingers. You can't see it with because I know 63 is something that's divisible by 9. So I would have to do 10, 20, 30, 40, 50, 60. So I know I need these fingers out for tens. I'm going to put down this finger, and then I have 1, 2, 3. So this is my 7th finger. So I know 9 times 7 is 63. So this division is going to be 9. So I know that 9 is equal to n minus 1, and adding 1 to both sides tells me that n is equal to 10. So this would be 10 weeks. All right, switching over to our question about angles. So I have interior angle of a triangle, a quadrilateral, and a pentagon. And our goal is to create an explicit formula that can be used to determine the sum of the interior angles for a figure with n sides. What they've done in part A here is told us exactly what we should label the heading of our table. So they said n sides. That means n is my input. So n is the sides. And an is the interior angles, or the number of degrees inside of that shape. So a triangle has 3 sides, and the interior angle is 180 degrees. Quadrilateral has 4 sides, with interior angles adding up to 360 degrees. And a pentagon has 5 sides, and they add up to 540. Now, these are going up by ones, so I need to figure out how much we're going up each step on the right side of my table. From 18 to 36 is 18, which means that this is 180 degrees here that I'm adding, and then I'm also adding 180 here. So that's good. This is our common difference. Here is my first input and my first output. So I'm going to have AN is equal to my first output of 180 plus my common difference of 180 times n minus my first input, which in this case is 3. Now I can use this to find the number of the total of the interior angles for a 12-sided figure by putting 12 in where I see n. So the output of 12 is 180 plus 180 times, this should be 12, 12 minus 3. So I have 180 plus 180 times, well, 12 minus 3 gives me 9. Well, if I have 9 180s here plus one more 180, This is the same as saying 180 times 10, which would be 1,800 degrees. And then last but not least, we've got this knee surgery question. Now this question, they tried to trick you because they gave you information about the first week, and then they gave you information about what's happening each day. So you have your surgery, and then for the first whole week, you're only allowed to run 12 minutes each day. So our first output is 12 minutes a day. We have to run that amount of time for the first whole week. So that means I don't start increasing for the first 7 days. So this is going to stay the same for the first 7 days. What's going to happen right after that, day 7 is the last day that I'm going to be jogging 12 minutes a day. And then day 8 is when I'm allowed to start increasing my jogging. And so my increasing, or my common difference, would be 6 minutes per day. So my formula here would be my 12 minutes a day that I was allowed to start with, plus my 6 minutes a day that we're going up, and then n minus 7, because for those first 7 days, I'm not allowed to increase the amount that I'm running. This 60 minutes for each day is going to replace my output here. So I'll have 60 minutes a day is equal to what we already had. And I'm going to start solving for n. Now I have to be careful, and I have to remember n is in days, and they're asking about how many weeks. So when we get our answer for n, we're not done. So I'm going to subtract 12 from both sides. This gives me 48 being equal to 6 times n minus 7. I'm going to divide by 6 first, just to make my life a little easier. 48 divided by 6 is 8. And then adding 7 tells me that n, can't see, is 15. Now this is 15 days. So how many weeks does it take for me to get to day number 15? Well, that would be 3 weeks.